As I mentioned in my first video, we're not just interested in the nth term, we're also interested in the sum of these terms. So let's look at the very simple example. Let's write a heading. Okay, let's look at the example 1 plus 2 plus 3 plus 4 plus 99 plus 100. I want to add these terms. The trick to this is to rewrite the series underneath, but start from 100 and work backwards. Now, if I add these two lines together, I end up with 101 plus 101 plus 101 plus 101 plus 101, 101. How many lots of 101s are there? There are 100 terms there, 100 lots of 101s. But I've added the series once and a second time. So this 100 times 101 is the series being added twice, because we added each term from this top series with the term from the bottom series. So I need to divide this answer by 2, which gives me 5050. So let's see if this works for some series which isn't so straightforward. Let's say we have 6 plus 11 plus 16 plus 21 plus 26 plus 31 plus 36. Let's keep it short so we can check the answer out. Okay, so the trick was to rewrite and add the two lines together. So that would be 36 plus 6, 42, 42, that's 30, 42, 42. You can see every single term is going to be 42. How many 42s were there? How many terms did I have? 1, 2, 3, 4, 5, 6, 7. 7 divided by 2, lots of 42s. That's 21 times 7, 147. Okay, let's test this out and see if we got the right answer. 6 plus 11 147. So let's write this in a formula that we can use so that we don't have to list the terms at every single time and see what the result is. So what's the pattern? You can see that if I take the first term and the last term and add them together, so my first term was 6, my last term was 36, every other term, when I list them in order, will end up with the same answer. So all I need to do to get this 42 in this case, or 101, is take the first and the last term. So let's call the first term A, as we have been calling it, and let's call the last term L. And then we ended up with all of these repeated terms, all of these repeated sums. And how many of them were there? Well, however many number of terms we had, because for every single term we are doing that addition. So usually we say n terms, and because we've doubled up the sum, we need to divide by 2. So sum of n terms is given by n on 2 a plus l, where N is the number of terms, A is the first term, and L is the last term. Now, the problem is sometimes I don't know what the last term is. Let's look at an example where we don't know what the last term is. Let's say we've got a series, and let's say it goes 73 plus 70 plus 67 plus, and so on. And I want the sum of, let's say, the first 200 terms. Now, since the question only states that I need to find the sum of the 200 terms of this series, and it hasn't told me that it's an arithmetic series, I actually need to show that it is. If the question, on the other hand, said find the sum of the first 200 terms of this arithmetic series, then I wouldn't need to show it. So let's start by first showing that this is an arithmetic series. And again, all you need to do is do t3 minus t2, which is -3, and t2 minus t1, which is -3, therefore arithmetic series. So the sum, I have my first term, I just worked out my common difference, I know how many terms I'm after, but I am missing the last term. And what I'm really trying to find is actually S of 200 terms. Since I don't have my last term, I can modify my equation slightly. So the equation was n on 2 a plus L. But I don't have L, so for the last term, I am going to use the formula a plus n minus 1d. And I am going to substitute 200 for n. I've got my a, I've got my d, and I can work out the last term. So the formula changes. Instead of having L in the formula, now I have a plus n minus 1d. And that can be simplified. So Sn is n on 2 2a plus n minus 1d. So this is the alternative formula for sum of n terms, and we need to know this so that we can work out the sum if we don't know the last term. So for our problem, S200, 200 over 2, 2 times a plus my n is 200, so that's 199 times the common difference of -3. We'll work that out on the calculator, and we've got the sum of 200 terms, resulting in -451. I expect that to be negative because the terms are getting smaller and we're looking for 200 terms. At some point the terms are going to be below 0, and if I keep adding negative terms, the total of the negative is going to outweigh the total of the positive.